Hello, welcome. In this short video, let us look at an introduction to linear systems. A linear system can be defined as follows. Consider for a system, the input x1 of t results in an output y1 of t, and another input x2 of t results in output y2 of t. Then the output to the input given by x1 of t plus x2 of t should be y1 of t plus y2 of t. And a scaled input, that is a times x1 of t plus b times x2 of t, should give a times y1 of t plus b times y2 of t. So if a system produces an output such that the linear combination of the inputs also results in the same linear combination of the outputs, then the system is a linear system. That is, for example, in this case, when you give the sum as the input, that is the sum of x1 and x2 as the input, you should get the sum of the corresponding outputs. Similarly, when you give the sum of the weighted inputs, that is a times x1 of t plus b times x2 of t, you should get a times y1 of t plus b times y2 of t. Then this system is a linear system. So the first property is known as additive property. That is, if the inputs are added, that is, if you give a sum of inputs as a total input, then the output, that is the total output, should be also the sum of the corresponding outputs. And the second property is called scaling property or homogeneity property or homogeneity. In this case, when you give a weighted sum of the inputs, you should get the weighted sum of the outputs where the weights are the same. That is, the weights do not change. So by generalizing this property, we can see that when the input is a sum of a weighted sum of the inputs xk of t, then the output should also be weighted sum. That is, the weights do not change, but the output should be the corresponding outputs. That means the overall output is the sum of the weighted sum of the corresponding individual output. And this property is known as superposition. Consider an input that has the structure xk of t is equal to ak of into t, that is time t. Then consider an output which is yk of t equal to b times xk of t. Then when the total input, or when a weighted input, that is x of t, equal the sum with index k of wk times xk of t, then the system is linear if the output is also equal to the sum k wk times yk of t. So if this is the output for this input, then the system then the system x of t gives y of t. That is, for this input we have this output. Then this system is linear if the output has the same structure as the input. That is, output is also a weighted combination of the corresponding individual outputs. Now let us look at another system which is not a linear system. That is, say we have y of t is equal to a times sine of x of t. So since sine is a nonlinear function, the system is also a nonlinear system. We can verify that by changing the input x of t to a linear combination of wk into xk of t. So if this is the input, then we can see that the corresponding output, that is y1 of t, is equal to a times sine of some k with index k wk xk of t, and the output y2 of t, which should be equal to the sum wk yk of t, where yk of t is equal to a times sine of xk of t. So for this input, this is the corresponding output, and this output y2 of t is a linear combination of all the individual outputs. But this one is not equal to this output A times sine of the linear combination of the inputs. That is, this system is a non-linear system. This is a non-linear system. Because the input is a linear combination of several inputs, the output is not the same linear combination. Then the system is a non-linear system. However, note that if the input x of t is equal to sine of t, which is a non-linear function of t, but when the output has the following structure, that is y of t is equal to say a times x of t, which is equal to a times sine of t, and this is a nonlinear function of t. But in terms of the relation between y of t and x of t, this is a linear system, because the input x1 of t equal to the sum wk xk of t. The output will be y1 of t equal to the sum wk yk of t, because the relation between y of t and x of t is linear. That means this system is a linear system, even though the function or the structure of x of t is non-linear. So the key point for a linear system is the relationship between the input and the output. If the relation is linear, then the system is linear, and it does not depend on the actual structure of the input x of t. Thanks for watching.